This is the second solving exponential and log equations video. These equations in this second half will mostly be solving, taking the log of both sides or solving a log equation. So this one here, we're solving for e. First want to divide both sides by 5. And no matter what, you want to keep your answers exact. I'm looking for an exact and approximate with this anyway, but if as you're going along you are using an answer that comes out to be an approximate value, use the calculator's answer. Now with e, I would take the ln of both sides since ln of e is equal to 1. I'm going to use capital ln, but you can use lowercase. Now could you use log with this? Sure. But since this is the case, it's going to make your life a whole lot easier. When you bring in that into the front, that 5x plus 4 to multiply, using the multiplying rule. Sorry, that looks funky. Hold on, let me just fix that. You almost don't even need to put this since it's equal to 1. So we get 5x plus 4 equals ln of 7 over 5. Subtract 4, divide by 5. I'm just going to show a couple steps for this, but not the actual workout for that. And with this, I'm okay with having what appears to be the fraction of fraction, but the 7 over 5 is part of the natural log, so you would keep that together anyway. So this would be your exact answer. And then the approximate, putting in the calculator. This one you wouldn't really need the fraction tool. I mean, you can definitely use it. But if you type in the numerator, hit enter, and then just divide by 5, you'll be in good shape for that. All right, and that's going to actually wrap up our exponential equations. The last few are log equations, whether we're switching to exponential form to solve it or we're just setting the two inside parts equal. So this one, first one, log base 3 of 8x plus 1 equals 2. If you have a logarithm on one side but not on the other, you need to switch to exponential form first. So we're going to make this 3 squared is equal to 8x plus 1. Once you do that, usually you have a fairly easy equation to solve. It depends if it's quadratic or not. In this case, this one's pretty straightforward. Now, for all of your log equations, you want to check that the inside of the parentheses is greater than 0, and also that the base is greater than 0. So I'm just going to plug in a value. I can kind of see this. You can do a visual check. So this is something right here. You can do that in your head or in the calculator, but you should always check your log equations because the domain of your logarithm is that inside of that parentheses is greater than 0, which we talked about with graphing. And the bases should also be positive. If there were a negative situation, that would really mean a reflection. So we would never get a negative base. That's part of our transformations. So here we're going to switch to exponential form. Now solving wise, I really could just take the square root of both sides. Just make sure to do plus or minus. You actually would get lucky on this one if you didn't do the negative, but in normal solving situations, you would want to do both. 10 is your only answer because 4, if I plug that into the base, we would get a negative base here. So bases must also be positive. All right, then we have 2 more. This one's kind of not in keeping with the 2 that we just did. But it's still, they're both logarithms. I'm going to do the e or the ln example at the end. So here's a little bit different. We have the logarithm on both sides. So it's kind of like having the same base for your exponential. The log with the same base, you can set the exponents equal, and in this case, the inside of the parentheses equal. This one has an added kick to it. It is not factorable, so there is good potential for some quadratic formula action on these problems, which is fantastic. Another good thing to make sure that we keep fresh. So you'd plug that all in. And this one just keeps on getting better because in addition to having the quadratic formula, it's a radical that simplifies. So our exact answer for this, and since I'm looking for exact and approximate, another good time to get this answer, but then also get the two approximates. And this is important to do for checking purposes because you want to plug these back in and make sure you're okay. So if I plug each of those back in to the x plus 7 and to the 2x squared minus 5x, both come out positive, so I'm good. I didn't show this, but I'm just making a note that you should plug in for checking. So these are your two approximates. And I kind of actually boxed off my plus or minus too quickly. Once you check the approximates, if one doesn't work, you want to eliminate that from your answers. And then our last one is going to be an ln example. This will be back to an easy solving one once we switch to exponential form. ln is the same as log base e. So if we're solving this as an equation, you want to switch it to log base e, change to exponential form. And if you recognize that it's log base e, I mean, you can change it right away to exponential form. Add the 4. Divide the 9, and then here's your exact answer. And then your approximate. Now I'm skipping over the calculation part, so if you want to just check out the calculating and make sure that you get the same approximate answers going along, pause the video and try it, and then you can restart it. I know I'm saying this at the end, but you could even go back if you haven't tried these out in the calculator into each of the problems and make sure that you're comfortable with the calculations. All right, so that's it for those two videos. You will now work on the practice, whether it's for homework or in class, depending on how these videos were assigned.